Hey guys, Mike here from Today Is Our Adventure. Solar can feel overwhelming, but in this series, we are breaking down RV solar systems from power needs and component sizing to optional upgrades so you can understand how off-grid power actually works. My goal with this series is to help you understand what you'll need for a successful solar build. That way, when you sit down with a certified installer, you can clearly communicate your exact power habits, your rig's limits, and your boondocking goals so that you get the right system built for your lifestyle. This video and accompanying web app are for educational and informational purposes only. Electrical systems carry inherent risks of fire, injury, or equipment damage. Always consult a certified RV solar installer or licensed electrician to design, engineer, and install your specific system. Work at your own risk. Before touching a single wire, we have to talk about step one, figuring out your actual power needs. Today, I'm showing you how technicians approach an energy audit and giving you free access to our custom web tool at solar.todayisouradventure.com to easily map out your system baseline. Throughout this series, you'll see me reference Victron energy components. Full transparency, Victron is not sponsoring this video, nor am I a distributor for their products. I use their equipment because of its reliability and system integration. That said, manufacturers like Renogy, Blue Sea Systems, and Magnum also build solid gear. Every rig is different, so work with your professional installer to choose the hardware architecture that fits your specific build and budget. When people ask, how much solar do I need? The classic answer is usually, it depends. That used to drive me crazy. However, there is a reason people say that. So let's talk expectations versus reality. Can you design a solar system that will power your rig with zero restrictions so that you can head off grid and never look back? Maybe, but it will be a massive build that costs a small fortune and weighs a ton. You will also still need a backup power source like a generator for those days when the sun just is not out. We'll also need to keep in mind that very few, if any, solar setups are going to be able to run all of your ACs in 105-degree weather in the dead of summer. That said, if you are willing to run only one AC, turn most of your appliances off when you aren't using them, and find boondocking spots at higher elevations in the summer, then we can significantly reduce your battery weight and get you on the road. So let's eliminate the guesswork by using an energy audit to figure out exactly how much power you will likely need for your rig and your boondocking dreams. If you haven't already, let's open up solar.todayisouradventure.com and click Start Energy Audit. Let's walk through what you'll need to gather in order to complete it. Number one, inventory and specs. Go through your rig and document the electrical specs on the data plates of every electrical device: fridge, AC units, CPAP machines, water pumps, lights, and chargers. If a tag is hidden, note the exact make and model so that you can look it up later. Number two, let's input that data and the expected camping temperature of your dream boondocking area into the energy audit page. On the top right, you'll find the camping temperature from the right-hand drop-down menu. So for example, if you're camping in 95 to 100 degrees Fahrenheit plus temperatures, the app is automatically going to add a 1x multiplier to your cooling appliances like the AC units and fridges to make sure that we compensate for the fact that they're going to have to run pretty much 24/7. Now enter your items line by line. Select voltage, then type in either amps or watts plus your estimated daily runtime in hours. Check the cooling box for any heat-dependent appliances like air conditioners, and check important for anything that you just absolutely cannot live without while boondocking. A quick safety tip here: if you're using AI tools to look up any missing appliance specifications, always double check those with the numbers against the manufacturer's official manual. AI can easily confuse running watts and surge watts, and accuracy really matters here. Number three, the reality check and gross vehicle weight rating warning. As you enter items here, look at the bottom bar showing your total daily and essential daily watt hours. When we ran our fifth wheel unrestricted in the Texas summer heat, we pulled 46,000 watt hours per day. To boondock realistically, most RVers aim to dial their daily consumption down to roughly 10 to 15,000 watt hours or less. So keeping in mind, bigger power demands mean more batteries and more solar panels, which adds physical weight and expense to your system build. Always check your RV's cargo carrying capacity and gross vehicle weight rating before planning a massive battery bank. Let's expand a bit on camping temperatures because your target location dictates your system limits. High heat environments like working a guard gate at a Texas facility without shore power require maximum solar yield and AC runtime. Shaded or northern spots like Alaska offer fewer peak sun hours and less cooling demand, but also require much larger battery reserves and a larger solar array if you want to stay out for any length of time. When planning your builds, factor in expected temperatures, travel days, and how long you intend to stay unplugged between pedestal hookups. If this breakdown is helping you with your off-grid goals, hit that like button and that subscribe button so you don't miss part 2. Now let's talk about battery sizing. So click that next button, and on step 3, your total energy daily demands are going to be at the top. If you exceed 10 kilowatt hours, the app is going to display a notice recommending you go to a 24 or 48 volt architecture. So here's where we choose our target system voltage and battery chemistry, keeping in mind that lead acid should only be discharged to 50%, requiring twice the actual amp hour capacity. Once you've entered that, the app instantly calculates your required amp hours for 1 full day of autonomy based on what you have entered so far. Under the desired battery specs section, you can pick from standard example batteries like Epoch, Big Beard, Lithium, SOK, or Victron, or enter your own custom battery specs. Just as a point of note here, we don't endorse any of these battery brands. They're just provided as an example to help you design your system. Products may change without notice, so you do your own research, and for best results, find a battery you like and enter it in as a custom battery. Moving up to 24 or 48 volts is popular because higher voltage allows for smaller copper cable sizes and higher efficiency on a 3000 watt plus inverter. But going higher than 12 volts introduces some real-world trade-offs. Number 1, the single point failure. Your RV slides, water pump, and 12-volt fridge require 12 volts DC. If you run a 24 or 48-volt bank, you must install a step-down converter. Cheap converters here can fail open, passing 24 volts directly to your 12-volt fuse panel and frying all of your electronics, potentially. Isolated, high-quality converters are a non-negotiable item if you decide to go with a 24 or 48-volt battery bank and not have any kind of in-between. So what do I mean by in-between? Well, number 2 is the maintenance trap. If you keep your old 12-volt lead-acid house batteries alongside a new lithium solar bank to try and isolate the two of them, your factory house batteries won't charge unless you install a dedicated DC to DC charger between them. Otherwise, those house batteries will slowly drain to zero while you're boondocking. Now let's talk number 3, motorhomes and alternators. In a motorhome, converting to lithium or a higher voltage requires an isolated DC to DC converter on the engine alternator to prevent your alternator from burning out while you're driving. Now let's talk number 4, 50 amp rigs have to be considered. You'll need either 2 inverters with a splitter and combiner box, or a specialized inverter like the Victron Multiplus 2X 120 volts, which supports 50 amps. Last but not least is number 5, generators. I'll talk about generators in another video. Just keep in mind here that any lack of solar or battery capacity while you're designing your system will have to be made up with a generator. Now let's click over to step 4 where we talk about solar charge controllers and solar panels themselves. Let's enter in the expected sun exposure for your boondocking area. If you don't know, you can use the average, which is about 6 hours per day. Once you do this, the app will calculate the remaining watt hours you will need for your solar build. Here's where we need our solar panel specifications. If you haven't chosen some already, go out, look at some, figure out what you need, pick some that will probably fit your RV build, and put these in here in this section. So let's enter in our panel specifications here that you found. You'll want to enter in your VOC or volts open circuit and ISC or current short circuit. When you do, the app is automatically going to add a cold weather voltage safety margin, and then it'll recommend a Victron SmartSolar MPPT controller showing you the max voltage and a potential charge output amps. But keep in mind, if you don't want to use Victron, that's fine. Just put your own specifications in here. Let's briefly cover what all that means. For example, an MPPT 150/30 solar controller, what do those numbers really mean? The 150 is the maximum input voltage from the panels that you can have on that controller. However, you will need to keep in mind that you must add at least an 18% safety margin to your total array voltage to compensate for colder temperatures. Solar panels can well exceed their listed volts open circuit or VOC in freezing temperatures. Failing to account for cold temperatures can result in catastrophic failure of the controller and possible fire hazards. The 30 in the controller is the maximum output amps of that controller that it'll put out to the battery. Here's how that breaks down. A 30 amp controller hooked to a 12 volt lithium battery charges the battery at around 14.4 volts. This means that the controller can push up to 432 watts of power to the battery or 864 watts of power in a 24 volt battery system. So to avoid clipping your panels or over paneling, you should choose a controller that has a higher wattage output than your solar array produces. Final consideration here is balancing your arrays and controllers for maximum power output. Is it possible to wire 4 panels in a series and then 4 sets of those in parallel and only use one massive controller to handle the entire array? Yes, it is possible. However, as amps go up, voltage goes down and vice versa. If you reach your controller's maximum amps with your array, you lose out on all that extra voltage from wiring them in a series. Also, the higher the amps you reach on the roof of your RV, the larger the gauge of wire you will need to get those amps down to the controllers, greatly increasing cost, weight, and power loss over that distance. This is where your installer will help you the most. They'll ensure that you get the maximum bang for your solar buck. Be sure to discuss this with them and base your choice of installers on that knowledge. Now back to the app. Once you click the final blueprint button on step 5, it pulls everything together into a single summary card, breaking down your energy demand, battery bank architecture, and solar arrays. Next critical step here is to click that green Print for Installer button on the blueprint page. Take that printout, your RV's vehicle payload specs, and your travel plans straight to your certified RV solar installer. Let them size your wire gauges, fusing, breaker panels, roof mounting hardware, and solar yield. Shortcuts on system engineering are the leading cause of electrical failures and RV fires down the road. In the next video in this series, we're diving into the heart of the system: lithium batteries, heating requirements, internal BMS protection, and system voltage selection. Don't forget to run your numbers through our tool over at solar.todayisadventure.com. Stay safe, build smart, and remember, today is your adventure.